Oh, hello. Welcome back to the show. My guest today is Juli Berwald. Juli is an ocean scientist, a science writer, and an author. The oceans contain some of the most mysterious places on Earth, and they have taken the brunt of the disruptions caused by climate change. Among these mystical places are coral reefs, the most productive ecosystems we know of, and they need our help. Juli has traveled the world to see and document humanity's best efforts regarding coral reef restorations and has joined me to discuss what the future of the seas will look like. Expect to learn how coral are adapting to warming oceans, what unsuspecting billionaire is funding coral reef restoration projects, why we may start shooting salt crystals into the atmosphere, where the most ambitious coral restoration projects are underway, how reefs can protect white sand beaches, and much more. Before we get started, you may be watching but not subscribed, and that means you might miss future videos. So click below if you're watching on YouTube and hit subscribe, or on Apple Podcasts or Spotify, click the plus follow on the homepage so you don't miss a show. But now, ladies and gentlemen, Juli Berwald.
I want to take this conversation right from the base and build on top of that. So, what are coral reefs and why are they important?
So coral reefs are, they are the most, there's so many ways to answer this question. But I think I'll start actually kind of big picture. Coral reefs are probably the most diverse ecosystem in the ocean. The coral themselves are animals. And I think that's like a really great thing to start off with. And they are animals and they support the entire ecosystem. So on land, we're used to thinking about plants as being the base of the support, the foundation of an ecosystem. You know, our forests and our wetlands and our grasslands, those are all plants that are sort of the structure around which everything else exists. But in the ocean, it's animals. And it is these coral that really support like a quarter of all marine life, which is a really outsized influence on the ocean because in terms of like area, the coral only take up less than 1% of the ocean. And yet somewhere around 800,000 species, not just like individuals, but like entire species depend on the coral reef at some point in their life. And okay, so back to the coral themselves. They are these animals and they are first cousins to jellyfish and sea anemones. So you can think about the shape of what a jellyfish is like a bell with a mouth underneath and then a bunch of tentacles. So kind of flip that over and you got basically a sea anemone or a coral polyp, which is the individual of a coral. But then what coral do is they team up and they form these colonies of lots and lots of polyps. And then they support those colonies with a skeleton. And, jellyfish and sea anemones, they are mushy and so are the coral animals themselves, but they secrete this skeleton. And the way they get the energy to do that is through photosynthesis, just like plants. So like it always comes back to photosynthesis in some way. And for the coral, what they've done is they've teamed up, they've formed this really, really deep symbiosis with an algae that lives inside of their cells. And that algae photosynthesizes and it makes sugar just like plants do on land. And the algae feeds 90% of the sugar it makes to the coral. And that fuel is what the coral uses to build its skeleton, which isn't so easy. It takes a lot of chemistry to do that. So if it weren't for this incredible symbiosis between the animal coral and then the algae, which photosynthesizes, the coral reefs wouldn't exist. And so it's just this incredible symbol of cooperation and how like two parts can be, greater than 2 + 2. So our 1 + 1. And so it's an incredible system. And the coral create these really, incredibly complex skeletons that then become the homes for lots and lots of animals to live on and around, just the way the forests, the trees create homes for so many other animals.
Absolutely. And one thing that really struck me in your book, there's a passage where you compare the efficiency of coral reef ecosystems to something such as a Middle America, Midwest sugar cane or wheat field.
Yeah, wheat field. Mm-hmm.
And essentially, I'm just going to read this. In tropical oceans, ecosystems typically produce similar amounts of organic matter as in deserts, about 0.2 grams of carbon per square meter per day. But on the coral reefs, the production of organic matter is 100-fold greater at 20 grams of carbon per square meter per day. That is the equivalent to a maximum productivity of a very efficient agricultural crop, like sugarcane growing under optimal conditions. A wheat field in the rich soils of Illinois that is fed artificial fertilizer is 10 times less productive than a coral reef. That blew my mind.
Yeah, no, it does. And just because of the oceanography of our planet, the tropical seas do not have a lot of nutrient inputs, or they haven't traditionally. And we can talk about how the oceans have been changing. But the big, rich parts of the ocean tend to happen in more temperate latitudes, and so those tropical places are real deserts, and so the fact that the coral reefs have this have created this rich ecosystem in a place where there shouldn't be enough nutrition to do that, it's super cool. It's mind blowing, actually, and so I think that we really need to pay attention to the coral reefs.
And let's talk about why that is. So you mentioned that the oceans are changing. I think that we've noticed, of course, this whole climate change movement has been a lot more mainstream in the past few years, as it should be. Can you go into some of the changes that the ocean is facing and how that impacts coral reefs?
Yeah. So, I mean, the top of the list, there's lots of answers to that question, but top of the list is that the ocean is warming. And the ocean, just because water, like thermodynamically, takes up heat better than air. So the oceans have absorbed 93% of the heat that carbon dioxide holds in our atmosphere. And so that means the oceans have offset the heating of the terrestrial systems, really. And so the oceans have almost warmed a whole degree Celsius already. And in different places, it's different, it's not just a blanket, but that's roughly kind of the global number. And coral, unfortunately, live within 2 degrees of their thermal limit. It's not the coral per se, it's really the coral algal symbiosis. So those algae that live in the coral's tissue, they, for whatever reason, when the ocean heats by about 2 degrees above average and then stays warm for, say a month or so, the symbiosis falls apart. And we don't know, it's shocking to think about this, but we don't know who pulls the trigger, who says I want to break this very productive relationship apart. If it's the algae saying I feel stress from my coral host, I don't want to be here anymore, I'm going to reveal myself to your immune system and get kicked out. Or if it's the coral saying, I'm feeling really stressed, I'm going to amp up my immune system and look for all foreign bodies that might be inside of me and kick out the algae. We don't know which of those two things is happening, but it happens. And when the algae leaves the coral, they turn white because the color comes from the algae. And so we call it bleaching. And if the symbiosis isn't reestablished within a couple weeks, the coral starve to death because the algae takes with it all that sugar that it usually is providing for the coral. And then the coral die. And it's estimated that half the coral have already died in the world. And there's probably no reefs that have been untouched by bleaching. And so it's a really, really significant problem. Other things, do you want other things that have changed in our oceans?
Yeah, please.
Are, as we have increased fertilizers up here on land to bolster our agricultural systems, a lot of those fertilizers end up in the ocean. And so these places that have evolved for millions of years to be deserts, like the coral reefs, are no longer as deserty. And that has led to a proliferation of diseases, because imagine that you're used to breathing fresh air all the time. And then there's particles in the air. Your immune system doesn't really know how to deal with that. And so it weakens you and you get diseases more easily. That's what's happening to the coral in these more polluted areas. A secondary factor with carbon dioxide in the atmosphere is ocean acidification, which is the pH of the ocean is dropping because of when carbon dioxide just mixes with water, it changes the pH. That can dissolve shells. Turns out coral seem to be doing pretty well. Like they seem to have systems in place to control that much better than we expected. So that's a teeny bit of good news. Not everywhere, but a lot of coral species seem to be kind of like, we got this when it comes to acidification. And there's overfishing, which just disrupts ecosystems and makes room for things like jellyfish to take a bigger role in ecosystems. But fishing itself can destroy coral by dredging, and blast fishing is a problem, like for physically exploding coral reefs. Dropping anchors on reefs is a problem. So we have problems in the seas. Yeah.
We have our work cut out for us, Julie.
Yeah. We have not really ignored, the health of the oceans. And that's really one of the big messages of, I would say, both my books is, the oceans, they keep us healthy, and we have not done a good job of seeing how important they are to our health.
While we're on the topic, your books, Spineless and Life on the Rocks, A Future for Coral Reefs, great books. If anyone is listening, please pick them up. They are wonderful reads. One thing that you touched on that I just thought of quickly, there is a main Ebola-like disease happening right now. It's spreading in the what kind of region would that be? The Gulf of Mexico now, and
in the Caribbean.
Caribbean, yes. Have we seen there being multiple variations of that disease? Is that problem getting worse, or is it relatively stable in terms of that genetic variation of that disease?
Okay, we don't know the genetics of that disease because we don't even know the pathogen. So, yeah. So this is this is a disease. I feel like it's an epidemic that has not gotten any attention, and it's really bad. In 2014, in Miami, they were dredging the port of Miami. Well, they just actually call it Port Miami to make it bigger for these Panamax ships. When they widen the Panama Canal, these bigger ships were able to go through it, and so the ports had to adjust, and so they had to dredge to make more space for these giant cruise ships. And so, right around the same time as that was happening, this disease emerged. And it's called stony coral tissue loss disease, but everyone calls it by its acronym, which sounds way happier than it is. The acronym is SCITTLE-D. And what it does is it attacks about 22 species of coral in the Caribbean, which is a very broad attack range. Like most diseases are much narrow, like maybe one or two species. This one, 22, that's a lot. They tend to be the kind of mounding corals, so not the real branchy ones. And it melts their tissue off, just like Ebola, like Jack said. And so it's terrible. It jumped off the Florida Keys. It went into Jamaica and the British Virgin Islands, the U.S. Virgin Islands. It's now made it all the way down to Curacao, which is pretty south in the Caribbean, and nobody knows how to treat it. And so when it shows up on a reef, people just kind of hope for the best because that's all we can do. And there's been very little luck understanding what the pathogen is. It seems to be waterborne, and that's about as far as if you put an infected coral next to a healthy coral, the healthy coral will get sick. But it's confounding and it's horrible, and the reefs are really being decimated by it.
So there's a lot of challenges going on. We will pivot into more hopeful, optimistic futures, I promise. I kind of want to take a little bit of a sidestep away from what is going on with coral, if you would allow me. I want to ask you, how did you become aware of all of these issues with coral? How did you embark on your journey to writing this book or going down this path to discovering the world of coral restorations and things that people are doing all around the world to try to help coral reefs?
So I grew up very landlocked in St. Louis, Missouri. I mean, we went on a couple vacations, like family vacations to the beach, but I mean, don't really remember much about that. But my junior year of college, I went on a study abroad program in Israel, and I was not really very, my program wasn't a good fit for me. I wasn't really making friends, and I was kind of depressed, and just, I wasn't happy at all. And I just was walking past this building, and I saw a sign on the wall, and it said marine ecology course in the Red Sea for 1 week during like a winter break kind of. And so I just signed up for the course because I was like, get me out of here. I'm not in a good place. And they put us on a bus and drove us down to the Red Sea, and rolled off the bus. And I looked around. It was like I had never been any place like this before. These crazy red mountains and this blue sea, and it was before you could even have time to sort of get your bearings in this incredibly beautiful and strange place. The teachers in the course were like, here's a snorkel, here's a mask, go get in the water, go get in the water. I'm like, how? I don't know what I'm doing. But I put my head underneath the water, and it was like, what? In the Red Sea, the corals grow very close to the beach, very close to shore. So you kick out like maybe 5 kicks, and suddenly you are in this fairyland of just incredible color and shapes and fish swimming everywhere and all these things waving around and this crazy like castle-like structures. And I was like, what is this? And I can't believe I live on the same planet as this. And I just decided I'm going to be a marine biologist. Like, it was crazy.
On the spot. Done deal.
I'm like, oh my gosh, I found what I want to do. There's a little more to it than that. I had been a math major in college, and we got out of the water and we got into a classroom, and the professor of who's a very famous coral biologist, started teaching us about these equations, which you could use to predict the abundances of different kinds of coral, depending on, like some coral are like kind of like, They preserve all of their energy. They don't grow very big. They grow kind of slowly. They don't put out very many, gametes into the water. Other ones are like, I'm growing super fast. I'm like a weed. And so you predict how these things abundances of these things in the environment. I'm like, oh my gosh, you can use math for biology. And it just made me so happy. I'm like, this is what I'll do. But life doesn't go in a straight line. And I did get my PhD, but in satellite oceanography. And then I actually fell out of academics when I got married and moved to Texas. And I started writing, and I wrote my first book, came out of an article I was working on for National Geographic about ocean acidification, actually, where it said that jellyfish would be winners in a future acidified ocean. And I was like, how much do we know about that? And I started digging into the literature, and I found out it was a crazy, nobody knew, and there were big fights going on, and there were so many interesting paths to follow to understand what was happening with jellyfish. So then after my jellyfish book did well, I kind of thought I have a good chance of writing another book. And, I sort of thought maybe I should go back to the coral, which is where my first love. But I was nervous because all of the stuff that we were talking about at the beginning of this podcast, how rough it is out there for the coral. And I didn't want to write an obituary for the coral. I started tiptoeing around, Google alerts and stuff about coral reefs. And I found this meeting in Florida called Reef Futures. And I went to this meeting, and it turned out that there were lots of people who weren't ready to write an obituary either. And so I decided I can tell these stories. I can tell these stories of hope and struggle and success and ideas and innovations around how we get more attention onto coral reefs, how we can hopefully protect at least some of them, and how we can start to recognize that they are part of the foundational health of our planet.
You said something very interesting there that I haven't heard you talk about before, so I'm personally very curious. You were in the textbook publishing industry for about a decade when you moved to Texas. How did you find yourself pivoting out of publishing into this freelance journalism, writing for National Geographic, and a bunch of other papers and publications? How did you make that transition?
Yeah, I mean, that just kind of, so I didn't start doing, I actually moved to Texas and I had a postdoc at UT, but that was the end of my academic career after that postdoc. I taught I taught biology for a year at a liberal arts college here, St. Edward's. And I thought I would be a good teacher and I wasn't. And so that was really hard for me. But then, like, I met a friend in a yoga class who was working at this publishing house, and she said, "You should apply for a job." And I did, and that's where I learned to write, was at the publishing house, because you have to be. I mean, you may not think about it really, but textbooks are kind of the distilled version of science, and you have to make every word count. That's why they're so hard to read, I think, because they have to be so crystal clear and simple. I mean, I know textbooks have complicated stuff in them, concepts in them, but they really have to be simple. And when things are so crystalline, your brain gets so tired reading that all the time. You know, when you're always reading something important, it's like our brains aren't made for that. We're made for conversation, where there are some interesting things, and then there's some fluff, and then there's some more important things. I think that's the way we're wired, and that's why textbooks are just so hard to read. But I learned a lot about writing working in the textbook company. Luckily, I had also had a friend who, in graduate school, who had already decided to become a science journalist, and he was working at U.S. News and World Report at the time, and so he had some access to freelancers who kind of were working with him in that world, and he started writing a little bit for National Geographic because he had access. And then they asked him to write a story, which was my very first story, about how water bugs walk on water. And I knew some physics, and Tom, my friend, didn't. And so he said, could you help me by writing this story? And I did it. And it was so wonderful to like write in that more mainstream voice as opposed to a textbook voice, that I was like, oh, could I do some more of that? And so I started asking for some pieces, and I met the editor, and I got to write a little bit more. It was really just luck and connections. So I think that goes to show, like, throughout your life, you know, just meet all the people you can, be nice to them. You just never know when things are going to come back in your favor. And so that's, I think, just good advice for everyone, you know?
I love that story. It almost seems like you mentioned that you crystallize your thinking a bit when you're writing such dense material as in textbooks. I think that paid you a great service, because in your book you strike a great balance between more memoir kind of writing, where you're recounting your experiences, going to all these places, meeting all these people, learning about all these restoration techniques, but then you also are able to convey technical scientific thought into stuff that is very digestible and easy for people to understand. So I think that is a great lesson to learn as well, is even if it's not something that you would ideally want to do, perhaps that you can build the skill in some area and then transition that into something else that would better suit you.
Yeah, thank you for saying that. And it is true. Like, I do feel like I learned so much from that textbook writing. I mean, basically, you can use half the words that you think you need to describe anything in science, like, really. And so I think that it's a good lesson for, I mean, maybe not, it's not just science. I mean, a lot of the times people will ask me to edit the work, and you can use half the words most of the time. So
I love that. Now let's pick up where we left off. Let's go back to coral. So we had just talked about, at the end of that, the coral bleaching, and explaining what that is and how we don't exactly know if it's the algae that initiates it or the coral. But either way, coral are resilient, very, very resilient. So they have been seen to create a new merger, so to speak. So the clad C, I believe, and now I'm getting a little bit out of my element. So Julie, please step in and correct me if I misspeak at all. Clad C.
Just clade C.
Clade, excuse me, not clad. Yeah. Clade C was the quoted algae that have created this relationship with coral, and they share about 90% of their photosynthetic energy, which is wonderful. As the relationship has broken down a little bit with environmental stressors, as we mentioned, that 2-degree threshold of coral, once we get to the upper end of that where things are a little uncomfortable, coral have been found to adapt and make a new merger with Clade D. I think I said Clade
That's
correctly.
right. Yeah,
Right? Awesome. Perfect. Clade D. Can you explain a little bit about that and what that means for the coral, for the reefs, anything at all?
Yeah, that's I mean, this is one of the coolest. It's sort of like in the weeds, right? Like in order to understand it, you first have to understand the symbiosis, and then you have to understand bleaching, and then you get to hear this like cool thing, So it does take a little work to get to this point, but I'm really glad you brought it up. And yeah, so like we don't, it turned out that until probably the 1990s, we didn't know that the coral can actually make these alliances with lots of different clades of algae, and it was around that time that this scientist named Rob Rowan, uh, he was a geneticist. He came into the coral world. He was like, there's no way that all those corals are just teaming up with one, clade of algae. And he did the genetics, and he found at least 4 different clades. And he just, for simplicity, named them A, B, C, and D. And those names, I mean, those designations sort of stuck for a long time. So that's what people call them. Now they actually have their own scientific names.
Which are probably far too hard for me to pronounce. So Clade C and D is what you get.
The C is called Cladocopium and D is called Duristidium. But
that sounds much easier, but I will think I will continue for C and D if you'd allow me.
Honestly, everyone says C and D all the time. So C's, right. So C's are very thermosensitive. They tend to bleach around 2 degrees warmer. D's can actually get you 1.5 degrees more than that. So they're less thermally sensitive. But there's a trade-off, which is that the D's only feed the coral about 65% of the photosynthetic sugar that they make. So it's like in the book, I think I do this analogy to like if you have a tenant and you're able to charge them like $100 a month, but then your air conditioner goes out, and so you get a new tenant and you only charge them $65 a month because that's all they're willing to pay because the air conditioner's broken. And so, but you just kind of are like, well, having a tenant is better than having no tenant, even if they're paying me less. And that's kind of like what the coral are doing right now, as the oceans don't allow them to make repairs to their systems and make them a less welcoming host. They're trading out for something that is at least going to pay them something, and whether or not what that's going to mean for the reefs long term, we really don't know. Doesn't look like all the corals are switching to Ds, but a lot of them seem to be. And the Ds do exist in both the Pacific and the Atlantic, so they're available to all of the corals. And yeah, we're sort of seeing this switch, and people are trying to understand like what is that going to mean for the reefs of the future. It's just one of those amazing, to be continued stories, but it's pretty cool.
I think this really underscores a key theme in your book, which is hope. There's a lot of things that are not ideal, a lot of things that are going wrong, but there is a lot to be hopeful for. And I think this is one of them. Even though it isn't ideal, we're not getting as much energy transfer as we would have with the Clade Cs, but the corals are hanging in there. I think that the analogy of the AC breaking is perfect. It's spot on. My question is, even though there's a reduction, there's still something coming in. So what does this mean for coral? How is this actually a big problem for them fundamentally, rather than, oh, maybe we just can't grow as much? Are there other more dangerous elements to this?
I mean, so the studies it's really just happening. So I got that, I wrote an article about this it's called symbiont switching. And the editor for that article was asking these questions to me too. And the truth is we don't have good answers to all these questions yet. Like, we don't know how switching to D will affect reproduction, for example. We don't know how switching to D will affect their ability to fight with other corals nearby. Like, we just don't know these answers. And so it's really hard. We're just kind of observing it right now. There is an interesting addendum to this, which is that we noticed that we mentioned how the oceans are becoming more polluted with fertilizers. So that will cause more free floating algae to live, phytoplankton, which is the base of the marine food web, and more zooplankton to be able to eat those phytoplankton. So there's more zooplankton in the water. Those are called more productive waters in places where coral reefs are. And corals, although they do get 90% of their energy from the algae that live in their tissues, they can eat. They're like jellyfish. They have a mouth, they have tentacles, they have stinging cells, they can sting zooplankton. So it's possible that as we pollute the oceans, we're also increasing the zooplankton load around where coral are, and they're going to make up for that deficit from the algae by eating more. And so we may be seeing that in some places. Again, this is like so speculative. I don't want to say we know this is happening, but it's possible that there is this other out for the coral, which is they could just start eating more. And so we just have to watch and see what's going to happen.
Man, it's so fascinating how nature finds a way.
Yeah.
Not to dismiss what we do up here, but nature finds a way, and it's very, very inspiring to see. Mm-hmm. One other question that I had with the C and D differentiation, we see coral switching over, so to speak, to the D brand of algae. When temperatures are increasing, things are becoming a little bit less comfortable. When that temperature comes down due to seasonal changes or weather patterns, currents, etc., are we seeing that switch back to C? So I guess to go back to your tenant example, are we locked into a 12-month lease, or is this a month-by-month sublet?
It's such a good question. We see kind of both. We see corals making different kinds of leases. They tend to be, this is one thing that a coral scientist will tell you, like, it's all over the place. Like, we're looking for patterns, and we're seeing some patterns, but like, you can always find variability out there. The corals there will be some individual colonies that will just surprise you and do something different than everybody else around them. So you'll see all kinds of leases being made out there.
One other question too. So again, in your book, Life on the Rocks, Building a Future for Coral Reefs, you are traveling all around the world to different reefs to visit people who are doing different things with restoration efforts or coral protection or preservation, et cetera, et cetera. Are there any specific projects that you found to be the most inspiring or fruitful?
Well, I mean, the most, just incredibly beautiful was this project I saw in Sulawesi, which is
where about?
That's in Indonesia. And so it's in the Western Pacific. And there is this part of the Pacific Ocean called the Coral Triangle. It's kind of a rough triangle. It's between Indonesia in the west, and then Palau, kind of a little bit east of it, and then the Philippines sort of north of those two in a triangular shape-ish. And that coral triangle is where the highest diversity of coral exist in the world. There's, I don't know, so like 600 species-ish of coral there. And that's compared to, say, somewhere around 60 species in the Caribbean. So 10-fold less in the Caribbean. This is a really high diversity. And climate change actually has not been as strong in that part of the ocean yet. But what has been happening there is this thing called blast fishing, where the fishermen, there's a lot of poverty, there's a lot of corruption. The fishermen are really just, trying to get by. And they use bombs they throw bombs into the coral reefs and stun fish, and then they can collect them. And it's illegal, but it's hard to enforce over a huge area of the ocean. And so when these bombs are thrown onto the reef, it causes a crater in the coral that will not heal. So the Mars Candy Bar Company has chocolate factories in this region of the world, and they realize that a lot of the people who work in their factories get extra sources of income and protein from the reefs. But they were having a harder time doing that as more and more of the reefs became bombed. And so they said, well, what could we do to help? And the head of the factory there is just one of these people who figures out how to make things. And he created these, they're called reef stars. They're rebar structures with 6 legs. And the local fishermen get broken coral, tie them on with zip ties to these 6-legged structures, and then they kind of network them together into kind of galaxies. And within about 18 months, the reef there will, in a bombed out spot, can be restored. And 3 years later, you can't even tell that anything had happened there. So seeing that kind of recovery is just so impressive. I mean, the one thing is they're working in a part of the ocean that is a great place to work. You got a lot of just general diversity around there, so you can get corals settling on these restorations. You've got a lot of fish and invertebrates that prune away macroalgae that take care of the coral, ready to go, ready to jump in and work on these restorations. And like I said, climate change hasn't hit this part of the world that badly yet. So, but seeing the kind of resilience is just, it's amazing. It's beautiful. And yeah, so that was probably the most beautiful restoration I saw.
As someone who, I wouldn't expect someone of the stature of Frank Mars to be in the game of coral restoration. So I guess it's also another lesson to take away is you never know who your allies could be, independent of people's perceptions. That's a very interesting point because coral reefs need protection. They need help. And this is not something that we can really do ourselves through turning off our lights at off hours. You should still do it if you can, but it's not really going to move the needle at the end of the day. So there has been 2 kind of outlooks, which you point out this dichotomy in your book as well. So Richard Beavers, who is a friend of yours, who worked on this amazing documentary called Chasing Coral, which is actually how I first heard about you, is at this Chasing Coral screening here in Austin. However, Richard Beavers and Frank Mars have 2 kind of opposing views of how to tackle this problem. Richard Beavers, coming from a marketing background, is more concerned about promoting coral reefs through advertising, whereas Frank Mars is more hamstrung on customers demanding this from corporations. So I guess, one, I want to point out as well that it seems very interesting that people who are so profoundly impacted by coral reefs, yourself included, are people who have had experiences with coral from a young age, which I guess speaks to the marketing side of it. If people are aware of the beauty and the fairy tale fantasy world of the coral reefs, they're more inclined to want to protect them. But speaking on that point of the marketing versus demand side, where do you land? Do you have an opinion on whether one or the other should be more prominent, or do we need both?
This is a question I've never been asked, so thank you for asking it. Yeah. The sad part is I think neither one have worked yet, right? So that's problematic. That we have not cracked this nut of how do you get people to care about the oceans. So I think we have to have everything we can think of at this point, but we clearly haven't thought of the thing yet that will get people more engaged with oceans. Richard's latest idea, and he may be onto something here, is that we don't teach children about oceans. I don't know about you, and I grew up in Missouri, but there was no ocean education growing up. There was no curriculum. There was no ocean curriculum in any of my education, even in college, until I went on that marine ecology class. it's not part of what we learn in school. Like the oceans are 2/3 of our planet. Why is there not a semester on oceans in 10th grade, or some grade, like what, and this is not just in the United States, it's all over the world. There are no ocean curricula. We learn life sciences, we learn physics, we learn chemistry. You maybe get a little bit of in your earth science class, like 2 weeks or a week. But like this is a big overlooked area that Richard may be onto something with this right now. So I don't know. I think that you don't care about things unless you know about them. You make a really good point. And so we have to somehow, we have to somehow come up with the thing. And I don't think we exactly know yet, but maybe it is this education idea that Richard's on right now.
I think that's a brilliant idea. I personally had no ocean experience until last year. I'm 25. I stepped in the ocean for the first time when I was 24 years old, and finding out about corals is just something that I would not have done in landlocked Toronto area, GTA, which is very interesting.
Yeah.
So that kind of brings us to the point of, okay, well, there may be a lack of awareness or people not understanding what the actual problem is. But if we were to do something, who is going to pay for it? And this is really, at the end of the day, is the crux of the problem. Money makes the world go round. You do point out in the book that the United Nations Sustainable Development Goals, life below water, garners the least philanthropic funding of all, just 0.56%. So why is this so low?
Right. I mean, I think this is dovetails to what we were just talking about, right? Like there's just less awareness about our oceans. We are terrestrial and they can be invisible. They can be just too invisible to us. So yeah, I think that this is the decade of the ocean. I mean, I feel like the United Nations recognized the fact that the oceans have been so overlooked, and they made this decade the decade of the 20s, the decade of the oceans. And so hopefully they're trying to like increase awareness about the ocean. I don't know if it's working. I really don't know if anyone knows that it's the decade of the ocean. And then there was also this global fund for coral reefs announced right at the end of the book in 2021 when it was finally announced. And so they're trying to come up with the first fund ever for coral reefs, which should be $500 million. It's actually off the ground, which it wasn't when I published the book. And they are starting to give out some grants through that Global Fund for Coral Reefs. So that's something. One of the things I talk about in the book are these like kind of really interesting investment instruments around coral reefs. So there are in Mexico's kind of the case study for taking out an insurance policy on the coral reef. And that has been really effective. The hotels and the tourism bureau kind of in Quintana Roo have come together and they have a policy on their reef. And so if the wind speeds get high enough to damage the reef, they don't have to even prove damage. They just have to get the wind speeds have to be above 100 knots. It pays out money for divers to get in the water and stabilize the reef. So that's actually been really successful, and it's spreading to other places.
So can we quickly just explain why that is? Why would somebody take out a insurance policy on a coral reef? What is the benefit to the insurer?
Oh yeah, I jumped over that leap of logic there. Coral reefs have been shown to be the best defense against storms of anything that exists. And a live coral reef can repair itself from storms, and it can deflect 97% of the storm energy coming towards land can be deflected by a coral reef. And so if you're worried about erosion of your beaches, if you're a hotel, if you have a healthy coral reef offshore, you're much less worried. And so there's actual value you can quantify the value of a healthy coral reef, which is, how much it would cost to restore your beachfront property if the coral reef wasn't there. So once you can put a value on something, you can insure it. And so that's what's happening. And it's a really interesting idea. And then there's also other ideas around debt swaps, which are kind of if a country has bad debt, they can swap it out for either a discounted debt or a better interest rate if they agree to protect some part of their coral reefs and make them into marine protected areas. So that's an idea that's also been spreading. And then the last thing are these blue bonds. So if you have a project you want to build that will protect your coral reefs, you can issue bonds. And this has been done on land. They're called green bonds on land. And that's also been very successful, especially with this growth of this SDG, sustainability, what is it? Sustainability, development and governments, I think. Which are basically like ways to get money from our capitalist society into environmental protection. And these things have been growing in favor. And so hopefully there will be more money directed at protecting our oceans through these really interesting new instruments.
So people came for the coral reefs and they're staying for the debt swaps, which is probably a curveball for many people. Can we maybe explain a little bit about what that means? So my interpretation is that a debt swap is a country that has issued debt to, say, another country and is now looking to have that repaid. Let's say that their economic circumstances change and the $1,000 or not $1,000, let's say $1 million. Let's project this out a little further. Their $1 million loan, say that they would collect 20% or something like that, just for simplicity's sake. Over time, they realize that they're not going to be able to collect this debt because things have gone sideways. So instead, they're allowing people to buy that debt at a discounted rate, so they get something back, and in exchange, they're providing this towards preservation. Is that kind of how that works?
Yeah, the country will agree to, say, make 30% of their coastal area a marine protected area. And then usually there's like a trust set up that throws off money that can be used to enforce that marine protected area. The debt swaps require someone like the Nature Conservancy coming in and acting, being the ones who buy that debt. And so they act as sort of the treasurer of the whole debt swap. But instead of having the United States having to like write off debt entirely, Belize just did a big one of these to Belize. They get something back. They get like maybe 80% of what they thought they were going to get back. Now the Nature Conservancy holds that trust, and instead of holds that debt, and instead of making Belize pay it back in dollars, they can actually pay it back in Belizean dollars. So in the local currency. So that gives them a break. And then they've negotiated better refinancing terms as well. But the Nature Conservancy considers it's a win because they've just protected 30% of the Belize coastline. And that's what their mission is. So, there's these trade-offs and everyone sort of gets something they want. Not everything they want, but some sort of gets what they want. And so that's why it's considered a win.
So these nature conservancies, are these nonprofits? Are these charitable organizations? How are they funded and operated?
So I'm actually specifically talking about the Nature Conservancy, okay, which is a nonprofit. It's the largest nonprofit in the world, and they have a nature trust. Like they have a huge trust fund. It's gigantic. I mean, $1 billion. I don't know. I'm not going to even say numbers. I don't know how big, but they have a huge financial arm that does things like this. And yeah.
Awesome.
Yeah, so take a look at the Nature Conservancy's work. They do great work, and they're very active in the coral world.
Gotcha. Now, with respect to time, I do want to touch on one very interesting thing that I found particularly engaging as somebody who is educated as an engineer, the concept of geoengineering. It's very interesting. It's very controversial, and it could be very promising or very scary. So can you just explain what geoengineering is for somebody who's unacquainted?
Yeah, I mean, it's very simply saying, like, we've got a problem with climate change. let's see if we can, and basically we have already geoengineered our planet by adding so much carbon dioxide to the atmosphere. We've changed our planet fundamentally. So can we do anything as a, like on the engineering level to protect, get rid of climate change, to mitigate climate change? And so there's a lot of ideas out there. And the one that we were talking, I talk about in the book is called cloud brightening. It does not get a lot of conversation around it. Geoengineering tends to be thought of as a very, very scary thing that we shouldn't talk about. We shouldn't do it. I mean, there's letters that hundreds of scientists have signed saying we should take geoengineering off the table. We don't know what the unintended consequences of geoengineering are going to be. And so, so it's like a third rail kind of thing we don't talk about. I think we should be talking about it. I think we should be talking about everything at this point, because like you mentioned, turning off the light switches isn't going to do it anymore. We need some sort of systemic change. And maybe we should evaluate the pros and cons of different geoengineering ideas. The one that I talk about in the book is one that's being used in Australia, or being investigated, I should say investigated in Australia. And the idea is that basically marine clouds are not quite as bright as clouds over land because they have fewer nucleators, which are just like little pollen or dust grains around which water molecules can form. And so if we add some more nucleators to those marine clouds, they just become brighter. It's like adding glitter to the clouds. And the obvious choice for what to add would be salt from salt waters, little salt crystals. So if you aerosolize seawater, you get little teeny micron size pieces of seawater, droplets of seawater with just like a little bit of salt in there. They go up to the clouds, they act as nucleators, you get a brighter cloud. And that reflects more solar radiation back away from our planet. And underneath those clouds, you can get a local cooling of around 2 degrees. And that is the magic cooling number we need to keep coral from bleaching. So, and it's not terribly expensive to do cloud brightening. It's, it's not cheap, but compared to some other things, it's something that's doable financially. It's also a regional scale thing. You could do it over, if a heat wave was coming towards you, you could do it over a region where the heat wave was coming. So it's being investigated. They did a demonstration project in Australia in 2020, right as the pandemic broke. I was supposed to be on that demonstration project, but Australia said no visitors. But it was successful. And so that project is going forward. They're doing more work to see if this idea will affect, like, for example, rainfall patterns or some other things that we can't think about. But I think the most interesting thing about cloud brightening is that in Australia, the indigenous communities they're known as traditional owners of the Great Barrier Reef. And so they have a say in all of the scientific activities that take place on the reef. And the indigenous traditional owners have said, we're okay with this because we're not adding or subtracting anything from the reef. We're moving salt from one reservoir to another one, the sky, for a couple days, and then it falls back into the sea. So they are actually so far saying, like, yeah, let's see what this might bring us. And I think it's incredibly interesting.
I love that they're doing thorough testing to see if there's any other knock-on effects that they aren't aware of, because that is the big concern with geoengineering, is these runaway effects that no one can predict until it's too late. So that's awesome. There's kind of two different realms of geoengineering which could be not ideal. So the first one is that disaster case that we just talked about and dismissed, luckily, because cloud brightening is something that is so localized and it dissipates very quickly. As soon as you stop pumping these salt crystals into the atmosphere, you essentially remove all the effects of it, which is great. So they are doing further testing, making sure that it does pan out. But then number two is a little more sinister because it's not so apparent. It's kind of a second order effect, which is if we're able to reduce the temperature in certain areas, does that just let the biggest polluters of the planet off the hook?
Yep. It's a great, okay. So this is a great question. Yes, absolutely. It does. But on the other hand, do we have time to worry about that right now? Like, don't we need to put a Band-Aid on the cut to stop the bleeding? and then, go back and figure out where the knife is and make sure it's not going to cut. That maybe isn't the best metaphor, but like, I think that just because the polluters can keep polluting doesn't mean we shouldn't try to protect our planet's climate. So we have to get off fossil fuels, but maybe we need methadone to help us do it. And we're not, the transition is happening, and the Inflation Reduction Act is really like creating these markets for alternative energy. And yes, it's not perfect, but it's a lot. And we can, we're already in Texas, which is so crazy. We're like over 20% alternative energy here in Texas. Nobody talks about that. So like, we are doing things already. And all those things need to keep happening. But do we buy some time for the corals by shading them when we need to shade them? And so I come out on the side of yes, like let's protect the corals if we can. But it is controversial. And yes, we do need to do it in a sober, very careful way. But we also can't forget that we've already geoengineered our planet. So I know what I'm saying is controversial, but I also think we need to be having these conversations. We can't just like say, no, I don't want to talk about it because it's controversial.
Maybe it's the engineer within me, but I totally agree with you. I think that we need to do something. I think that right now, what we would like to happen, which is, hold the oil and gas companies' feet to the fire, so to speak, it's not going to happen, at least not right now.
It's going to happen. It's just right, but it's just not going to happen fast enough.
Exactly. Yeah. To try to tie this off on a high note, which we're now talking about these hopeful things, geoengineering, all these things that are hopefully not destructive and very helpful. What gives you the most hope for the future of coral reefs? I just heard recently that you were talking about some big project that's happening in the Red Sea, coincidentally, where you first fell in love with coral reefs. Could you maybe talk about that a little bit more, or explain other things that are giving you most optimism and hope?
I'll just mention so in the book, I talk about these coral restoration projects. Since the book was published, it's only been a year, but there have been the announcements of some even bigger ones, these things called mega projects, which are like 100 square kilometers, and they're in the Red Sea. Saudi Arabia is funding these projects. They have the money to do it. They want to be the leader in coral restoration, and they are going after it. So we'll see what happens with that. There's been one of these projects announced. I think there's more in the works. And so this is maybe the future of coral restoration. We'll have to see what they do. But I kind of want to pivot away from that and say that I just came back from the LA Times. I just came back from the Los Angeles Festival of Books last night. And what really gives me the most hope is that when I started talking about climate change for my jellyfish book, I would go to book festivals and my panel would be maybe half full. And I would bring up climate change, and I would be like really struggling to talk about complicated, or maybe not complicated, but some of the details surrounding climate change, like geoengineering, or the fact that the oceans have taken up 93% of the heat, and the different complexities around it. At this panel was sold out 3 days before the festival started. People were lined up to get into the room in case people didn't show up, in case there was a waiting line to get into this panel. That's what gives me hope, is the fact that there are so many more people aware of what we're doing to our planet, how much it matters. They want information. People want to be engaged. They want to know what's happening. And so that is where I feel like the hope is at this point.
Juli Berwald, ladies and gentlemen. Juli, what do you have coming next? If people want to follow you or follow your work, where can they go?
JuliBerwald.com. My parents never gave me an E, so it's just JuliBerwald.com. I've hit all my talks on there, my most recent articles. All of that is available on my website. I keep it up to date. And I think that's the easiest way to get in touch with me. there's you can contact me too on that through the website.
Juli, thank you so much. I really do appreciate your time.
Thank you so much, Jack. This was a pleasure.